This is lesson IA2 on exponents. I am hopeful that most of this information is going to be review, but it may be a well-timed review as we move into more complicated algebra topics. I have listed on the screen right now the properties that govern exponents, and they are usually just called the rules of exponents. And so I will briefly mention each one of these before we start using them. The first one is the power rule. Make it a little bit larger. And the power rule, as it says that if you have a base raised to a power, and then that entire quantity is raised to another power, then you find the value by keeping the base and multiplying the exponents. That's the power rule. You'll notice it always has parentheses. Next is the product rule. If you have the product of a base to a power times it has to be the same base to any power, then to find that product, you add the exponents, and in this case I would get to the seventh. The quotient rule is the inverse of this. If you have a base to a power divided by the same base, it must be the same base to a power, then you keep the base and you subtract the exponents. In this video, I'm not going to go through and do what might be considered not a proof, but at least a convincing argument about why these work. I'm instead just reminding you of these properties. The next one is the negative exponent rule. Sometimes this one is not quite as intuitive. If you have any base to a negative power, I call it the move me rule. You take the base with the negative exponent, move it, if it is in the numerator, move it down below to the denominator, change the exponent to positive. If there are other factors in the numerator, you leave them. If there are not, you put a 1. It's the move me rule. The last one, if you have any base other than 0, and raise it to the 0 power, you get the number 1. I'm not going to try to trick you with this, but if you have 0 to the 0 power, this is undefined and has no value in the real number system. So those are the rules for exponents. If we need to talk about all of the rules for polynomials, we'll come back to that. All right. In this lesson, the problems I want to practice with, the first thing you're going to do is evaluate. And remember that means find the value of. You're going to use your order of operations. Please excuse my dear Aunt Sally. So let's see what we've got. We've got 6 to the second power times 4. Exponents, 6 to the second power is 36 times 4, which gives me 144. This can be done on the calculator. Let me grab that. If you had 6 squared, is the x squared key is right over here, and it is times 4, and press enter. That is a quick way to get 144. All right. The next one, it asks me to evaluate the base -3 to the second power. Because that base -3 is in parentheses, it is -3 times -3, which is +9. If what appears to be a negative base is raised to a power, if it's not in parentheses, then it's really not a negative base. This could be read as opposite of 3 to the 4th power. But they do that by writing minus and then 3 to the 4th power. This is negative in front of 3 times 3 times 3 times 3. That negative carries over, and it's negative 81. We can verify those things with our calculator. If you have open parentheses, negative 3, close parentheses, squared, and press enter, you do get positive 9. And if you have negative 3, and it was raised to the 4th power. Now, this is the first time I've shown this on the calculator. If you're raising to something other than squaring, there are a few other ways to do it, but I usually use the exponent key, which looks like a housetop. It may actually draw the housetop on your calculator, or like this one, it actually just opens a little exponent box for the 4 to go into. If you're going to do something else, like multiply that by something, you may need to use your right arrow key to get it out of the exponent, but I didn't need to do that. And press enter, and you notice that it does indeed call it negative 81. Number 4, use the 0 exponent rule. The base is negative 2 raised to the 0 power gives me 1. Number 5 says what's negative 9 to the 0 power. Because it does not have parentheses, the negative is not part of the base. It simply means opposite of 9 to the 0 power is 1. So that value is negative 1. Question number 6. We're supposed to simplify 4 raised to the negative 4th power. Hopefully you remember, that we will say that this means move me. It will move to the denominator, and the exponent changes to positive. There's nothing else on top, so I'll put a 1, and that will be 1 over 4 times 4 times 4 times 4 is 256. You would have to be careful if you did this with your calculator and you had 4 raised to the negative 4 power, and you pressed enter, you're going to get a decimal. Now, there are ways sometimes to get the calculator to accurately change that to a fraction for you. If you went to the math key, the very first item, that means change whatever you got to a fraction. You can either press a 1 to choose that, or you can press enter. And so it's saying, you want me to change the most recent answer to a fraction. Yes, hit enter. And there it is, 1 over 256. Very powerful calculator. All right. Now we're going to use more of the properties. Use the properties of exponents. All right. I have 2 to the 6th times 2 to the 2nd. That is the product. So I'm going to use the product rule. I'll just make a little note of that. So that's 2 to the 6th plus 2. That is 2 to the 8th. And you notice that it says leave your answer in exponent form because these values are going to get too big. The next one, this is a quantity raised to an outside power. This is the power rule. Product rule because it was the product of like bases. Power rule because it was something to a power raised to a power. And in this case, I'm going to get 4 to the 4 times 3, which is 4 to the 12th. On number 9, this is the quotient rule. And I'm just abbreviating some of this. And the quotient rule says keep the base, take the numerator exponent, and subtract the denominator exponent. That gives me, That gives me the base of 5 raised to the 4th power. Now on number 10, there are a couple of different things you could do, but I'm going to recommend that you use the rules in the order that they are listed right here. So I'm going to recommend that you use first, ask yourself, can I use the power rule? Can I use the product rule, quotient rule, if I have a negative exponent, and then the zero rule. So that's my recommendation. That is not a rule of algebra, but I think it's a very good idea. So is it power rule? No. Is it product rule? Yes. The product rule says keep the exponent, keep the base, and add the exponents. There is no exponent written here, so it is an implied 1. So the new exponent will be negative 6 plus 1, which is 9 to the negative 5. Now, as I go through the rest of the rules, there is no quotient. There is a negative exponent, so I have a second step, and I will move this, so I'll get 1 over 9 to the positive 5. So in this problem, I used product rule first, and then I used negative exponent rule. So this is just like a shorthand notation about if I used more than one rule. On this one, power rule, no. Product rule, no. Quotient rule, yes. So the quotient rule says keep the base, take the numerator's exponent, subtract the denominator's exponent. That gives me 7 to the negative 2. Well, I ended up with a negative exponent, so now I will use the negative exponent rule, which is the move me rule. That gives me 1 over 7 squared. It did not say leave it in exponent notation, so I'm going to write this as 1 over 49. Now let me go back and see. Let's see. On problem number 8, we left it. 9, I left it. And 10, I left it. Let me double check and see if it wanted me to go any further. All right, I've backed up because, well, let's see. Number 7, it did this, but on number 8, it did not ask me to leave it in exponent form. I'm really surprised about that, but let's just see if we can do it. If I go to my calculator and I clear it off and I have 4 raised to, was that the 12th power? And so I'm going to write this number down, assuming I could remember it, 16,777,216. So back over on the other page. I'm looking for where that, here it is. Evaluate this into large number. Okay. If I want to use the calculator to do these, I can. I really don't know that I want to take the time to say, okay, what is 5 to the 4th power? 625. So on these, you can go in and just grab your calculator and do it. For this one, the easiest way would be to put 1 over and then go to the calculator and say what's 9 raised to the 5th power. And it's 59,000. 49. Luckily, we do have a calculator to handle these large ones. So if it doesn't say to leave it with an exponent, then you need to use your calculator and expand it. All right, with number 12, we don't have, oh, I was going to put my rules here. Here I used a quotient rule, and then I used the negative rule. So I apologize. I backed up because there were some of them that it did not tell me to leave it in exponent form, so I really needed to use my calculator and get the values. Well, number 12, it says simplify this expression, and I don't have numbers, I have variables. So if I have x, y to the negative 3, what I really want you to realize here is that only the y is being raised to the negative 3 power. So that's the quantity that's going to move down. So there's the y to the third. This time I have something to leave in the numerator. I have x. Number 13, there are a couple of ways you could do it. If you use the product rule, this would be the base x to the 0 plus 6, which is x to the 6th. Or you could have identified immediately that x to the 0 times x, let me back up because I didn't read those letters correctly. You could not do what I just said because those aren't the same base. I'm so sorry. All right, this is going to be x to the 0, y to the 6th. So this is 1 times y to the 6th, which is y to the 6th. And I'm sorry, I misread the problem. The next one, though, does have two different powers of the same base. So I'm going to use the product rule because that's a product. So it's x to the negative 4 plus 6. That's x to the 2nd. And that's all I need to do. Number 15, power rule. That's going to be base x to the 11 times 4. That is x to the 44 power. Thank goodness those are not number bases because I would have a lot of trouble thinking about raising some number to that particular power. All right, so if I wanted to back up and make little notations, here I used the 0 rule. Here I used a product rule. Here I used a power rule. It looks like number 16 is another case of a power rule. That means it's going to be x to the negative 3 times 5, which is x to the negative 15. But I don't get to stop there because that's a negative exponent. It says move me. That base will move to the bottom with now a positive 15, leaving a 1 on top. So I used the power rule, and then I used the negative exponent rule. Number 17, quotient rule. This is going to give me y to the 9 minus 6, which is y to the 3rd. And that was only the quotient rule. Number 18. Number 18 is a power rule, but it is the power of multiple factors inside there. So each factor inside is going to get raised to the 2nd power. So I'm going to get 6 raised to the 2nd power, y to the 6 times 2. Remember that original 6 had an exponent of 1. That's why I have this 2. So 6 to the 2nd power is going to be replaced with 36, y to the 12th power. So this one was power rule. Number 19, very similar. The constant right here, that coefficient, has an exponent of 1. So the outer 5 is going to affect all of those. This is going to be negative 5 raised to the 5th power times x to the 3 times 5 power times y to the 2 times 5 power. Now I'm going to go to my calculator and put in clear, open parentheses, negative 5, close parentheses, raised to the 5th power, negative 3125. Nope. Okay, we get a little thing opening here and there. And let me close that. All right, sorry. So this is equal to negative 3,125. That's negative 5 to the 5th power, x to the 15th, y to the 10th. That was the power rule. All right, now we have what looks like a product. We're going to multiply the numerical coefficients. 5 times 5 is 25. X to the 3 plus 4 power. The operation is multiplication, but remember the way that we multiply like bases is by adding their exponents. So this is 25x to the 7th. That was the product rule. Next, looks like a quotient. I'm going to divide the numerical coefficients. They're just plain numbers. So let's divide those. That will give me 2. Now I'm going to use the quotient rule with the exponents, x to the 8 minus 5, which is 2x to the 3rd. Right, number 22. It looks like I have a power rule. The big 4 is getting raised to the negative 4 power, and so is the x to the 4th. So I'm going to have 4 to the negative 4th power, x to the 4 times negative 4. That's what the power rule says. So this is 4 to the negative 4, x to the negative 16. This factor is going to move down, and this factor is going to move down. That means I have a 1 left on top, 4 to the positive 4th power, x to the positive 16th power. And then if I need to know what 4 to the 4th power is, and so off screen I can do that, and I get 1 over 4 to the 4th power is 256, x to the 16th power. Let's look at 23. This appears to be a quotient. Now, with these numerical coefficients, I cannot divide 42 into 35, but I can reduce the fraction. 7 is a common factor. 7 goes into the top 5 times, 7 goes into the bottom 6 times. And then let's just push this like that. Then if I use the quotient rule with the x's, I have x to the 3 minus 7, y to the 5 minus negative 3. You have to be careful with that. That means that I have 5, 6, x to the negative 4. Now what does minus minus mean? It means plus. Y to the 8th, because that becomes plus. All right. I still see a negative exponent. That means that this needs to move down. The 5 is a numerator. The y to the 8th has not moved down. I know it didn't look like it was in a numerator, but it was over an implied 1 over. The 6 was already a denominator, and now the x to the fourth is in the denominator. So I did use the quotient rule there, and then I turned around and used the negative exponent rule. All right. What does number 24 look like? Anytime you have parentheses with an exponent on the outside, it is power rule. Every factor is going to get raised to this power. So this is 6 to the negative 2. X to the 5 times negative 2 is negative 10 over y to the negative 2. When you don't see an exponent, like on the 6 or on the y, you know it's a 1. You multiply the outer exponent times 1. All right, I have negative exponents everywhere. Every factor is going to move. The 6 to the negative 2 goes down. The x to the negative 10 goes down. The y to the negative 2 goes up. So I end up with y to the second over 6 squared x to the 10th. And because it wants me to expand that, I have y to the second over 36 x to the 10th. So I used the power rule, and then after that I had a lot of negative exponents to take care of. Let's look at number 25. Looks like there's a good bit to do here. But I start out and I see parentheses with an exponent, so it is power rule. What gets raised to the third power? Well, it is in parentheses, negative 16 to the third power, a to the 2 times 3, which is 6, b to the 6 times 3, which is 18. Remember, power rule means you multiply the exponents. Over 4 to the third power, a to the 10 times 3, which is 30, b to the negative 4 times 3, which is negative 12. All right, we only have one negative exponent right here. That's the only thing that's going, whoa, I'm so sorry, I jumped the gun. I have a quotient here. I'd like to go ahead and multiply these numerical coefficients. Using my calculator, negative 16 to the third power is big. It's negative 4,096, a to the 6th, b to the 18th, over 64, a to the 30th, b to the negative 12. Now, remember the order that I said. It was power rule? Yes, I just used it. And I went ahead and raised those numbers to their powers. Now, are there any products of like bases? No. Are there any quotients of like bases? Yes, and I almost overlooked them. I am going to divide 64 into negative 4,096, and it actually goes in there negative 64 times. So I did that traditional division. And then I have a to the 6 minus 30, b to the 18 minus negative 12. You have to be so careful when you have minus a negative exponent. Remember, it's top exponent minus bottom exponent. So this is negative 64, a to the negative 24th power, b to the minus minus turns plus 30th. So you might not have expected it earlier, but this is the factor that's going to move. That's negative 64, b to the 30th, over a to the 24th. Now, could you do things in another order? Could you have moved this b to the negative 12th up here? Yes, you could have, and then it would have been a product in the top. You would have gotten exactly the same answer, but if you will go in the order that I mentioned, I think it will be easier. So in this problem, I used the power rule. Everything got raised to the third power. Then I used the quotient rule. I did a lot of subtracting of exponents right here. And then I had a negative exponent to move. All right, number 26, and we're tired and we're thinking, oh my goodness, not more. But look at this exponent. We have a complicated base raised to the 0 power, and that means it's equal to 1. So yay. All right, I'm going to rather quickly go through scientific notation because I think you have seen this before, so I'm not going to develop the whole idea. Just remember that when you have a positive exponent, that means, and this is just casual language, big number. When you have a negative exponent, and you know that that usually means things go into the denominator, and what happens is you have a tiny decimal. All right, so what I'm given here on number 27 is scientific notation. They would like me to change it back to what's called standard notation. If I'm going to multiply by a power of 10, every time I multiply by a power of 10, the decimal point moves 1 to the right. I'm multiplying by 5 powers of 10. So I'm going to take 4.2 and I'm going to move it 1, 2, 3, 4, 5 places to the right. I'm going to fill in with zeros. Then I'm going to rewrite the number because that is very hard to read. And let's see, it is going to be 420,000. And it follows what I said up here, that a positive exponent represents a very large number. I don't have students memorize move right, move left. All I do is think about big and little. Number 28. This time there's a negative exponent. And when you have a negative exponent, it means a tiny number, and to make the number 9 get smaller, we're going to move the decimal to the left. So that's dividing by 1 power of 10, 2, 3, 4, 5, drop the decimal. 0, 0, 0, 0. Some textbooks like to put a leading 0 in front of that. I think it can get confusing, so I don't. This is just 0.00009. Negative exponent, tiny decimal. Another one, positive exponent. It's got to get bigger. So it's negative 7.65. That's multiplying by a power of 10. A second one, a third one, a fourth one. Fill in with zeros. That is negative 76,500. And so I guess literally someone might want to argue that a negative number was not big, but its absolute value is big. So I'll leave it at that. Number 30, negative exponent, which means like it had moved to the denominator. It's going to be dividing by powers of 10. So I have negative 4.27, and we're going to go 1, 2 places to the left. That gives me negative 0.0427. Now we're going to take standard notation numbers and put them in scientific notation. Now the first thing I'm going to say about this is very important. This number is 318,000. In scientific notation, the decimal point must come to the right of the first digit. In order for the decimal point, which starts out right here, in order for it to go here, it would have to move 1, 2, 3, 4, 5 places. So this is going to be 3.18 times 10 to the, now is it going to be a positive 5 or a negative 5? It's a big number. Put positive 5. So once I have determined that the decimal point goes here and it takes 5 moves to get there, then I don't write these zeros down. They don't show up over here. All right, let's look at another one. The original decimal point is right back here. I'm going to write this. This is 620 million. I hope those commas don't bother you. The original place of the decimal is right here at the end. In order to get where it needs to go for scientific notation, it needs to move 1, 2, 3, 4, 5, 6, 7, 8 places. This will be 6.2 times 10 to the, I moved it 8 places. It was a big number, so it's positive 8. Number 33, the number is 0.00038. In order for this to be in scientific notation, the decimal point must go here. Remember, it has to go to the right of the first non-zero number. To get there, it has to move 1, 2, 3, 4 places. And when it moves, so that's going to be 3.8 times 10. Now, it moved 4 places, positive or negative? It's going to be negative because this is a tiny decimal. All right, I believe that concludes our lesson. This hopefully was all review. Hope I'm not making you dizzy here. And the main thing that you needed to do was become comfortable with using these properties or rules of exponents.